Hi all, today we are going to discuss about measurement of power. So, the power is defined as the quantity of energy dissipated or stored per unit time. This power is divided into three categories: low power, medium power and high power. Low power is less than 10 milliwatt and medium power is from 10 milliwatt to 10 watt and high power is greater than 10 watt. So the general measurement technique for average power is to attach a properly calibrated sensor to the transmission line port at which the unknown power is to be measured. So the output from the sensor is connected to an appropriate power meter. The R of power to the sensor is turned off and the power meter zeroed. This operation is often referred to as zero setting or zeroing. Power is then turned on. So the sensor reacting to the new input level sends a signal to the power meter and the new meter reading is observed. There are three popular devices for sensing and measuring averages power at RF and microwave frequencies. Each of the methods uses different kind of device to convert the RF power to a measurable DC or low frequency signal. So these devices are the diode detector, the bolometer and the thermocouple. So the diode detector, first one is the low barrier Schottky diode technology, which made it possible to construct diodes with metal semiconductor junctions for microwave frequencies that was very rugged and consistent from diode to diode. So these diodes, introduced as power sensors in 1974, are able to detect and measure power as low as minus 70 dBm, which means 100 picowatt at frequencies up to 18 gigahertz. Next one is bolometer sensor. So the bolometers are power sensors that operate by changing resistance due to a change in temperature. The change in temperature results from converting RF or microwave energy into heat within the bolometric element. There are two principal types of bolometers: barometers and thermistors. Barometer is a thin wire that has a positive temperature coefficient of resistance, and thermistors are semiconductors with a negative temperature coefficient. So thermistor elements are mounted in either coaxial or waveguide structures, so they are compatible with the common transmission line systems used at microwave and RF frequencies. So these power meters are constructed from balanced bridged circuits. The principal parts of the power meter are two self-balancing bridges, the meter logic section and the auto zero circuit. The RF bridge, which contains the detecting thermistor, is kept in balance by automatically varying the DC voltage. VRF, which drives the bridge. So the compensating bridge, which contains the compensating thermistor, is kept in balance by automatically varying the DC voltage VC, which drives that bridge. The power meter is initially zero set by pushing the zero set button with no applied RF power by making VC equal to VRFO. VRFO means VRF with zero RF power. So after zero setting, if ambient temperature variations change thermistor resistance, both bridge circuits respond by applying the same new voltage to maintain balance. And the next one is thermocouple sensors. So it have been detection technology of choice for sensing RF and microwave power since their introduction in 1974. The two main reasons for this evaluation are they exhibit higher sensitivity than previous thermistor technology and they feature inherent square law detection characteristic. So input RF power is proportional to DC voltage output since the thermocouples are heat based sensors. They are true averaging detectors. Thermocouples are based on the fact that dissimilar metals generate a voltage due to temperature differences at a hot and cold junction of the two metals. The power sensor contains two identical thermocouples on one chip and electrically connected, which is so shown in this figure. And measurement of low power. So the measurement of microwave power around 0.01 milliwatt to 10 milliwatt can be understood as the measurement of low power. So bolometer is a device which is used for low microwave power measurements. The element used in bolometer could be of positive or negative temperature coefficient. For example, a barometer has a positive temperature coefficient. Hold resistance increases with increase in temperature. And thermistor has negative temperature coefficient whose resistance decreases with the increase in temperature. Any one of them can be used in bolometer, but the change in resistance is proportional to microwave power applied for measurement. So this bolometer is used in bridge of the arms as one so that the imbalance cost affects the output. So the millimeter here gives the value of the current flowing. The battery is a variable which is varied to obtain balance when an imbalance is caused by the behavior of the bolometer. So this adjustment which is made in DC battery voltage is proportional to the microwave power. The power handling capacity of the circuit is limited. And how the medium power is measured. So the measurement of microwave power around 10 milliwatt to 1 watt can be understood as the measurement of medium power. A special load is employed which usually maintains a certain value of specific heat. The power to be measured is applied at its input which proportionally changes the output temperature of the load that it already maintains. The difference in temperature rise specifies the input microwave power to the load. So the bridge balance technique is used here to get the output. The heat transfer method is used for the measurement of power, which is a calorimetric technique. So how the high power is measured? So it is around 10 watt to 50 kilowatt can be understood as the measurement of high power. So the calorimetric wattmeter which can be of dry and float type. The dry type is named so as it uses a coaxial cable which is filled with dielectric of high hysteresis loss, whereas the flow type is named so as it uses water or oil or some liquid which is a good absorber of microwaves. The change in temperature of the liquid before and after entering the load is taken for the calibration of values. So the limitations in this method are like flow determination, calibration and thermal inertia. So the power is measured in the three terms: low power, medium power and high power with help from thermocouple sensors, and the bolometer sensor is explained and diode detector is explained.